I'm Rama Krishna Malladi, a faculty member in the Department of Material Science and Metallurgical Engineering at IIT Hyderabad. My area of research is transmission electron microscopy, in particular in situ transmission electron microscopy. And my objective of teaching this particular course, transmission electron microscopy, theory of imaging to advanced applications, is to prepare the audience who are attending this course to be ready to handle the microscope hands-on. The whole objective is to give you a brief introduction of TEM and then take you through demonstration sessions where I'll show you the various operating modes. I also want to see that you are prepared to see what to expect when you go to a microscope. How do you load the sample? How do you do the basic alignments? How do you do the imaging? And eventually, how do you do the analysis? So with this, let me just go to the very first lecture of today, which is on basic introduction to transmission electron microscopy. Now, we all know microscopy is a very important area across various fields of research, be it physical sciences, chemical sciences, biological sciences, material science. Everywhere you use microscopy as a tool of characterization. Now, why do we need to do this microscopy? If I'm preparing some kind of a material and I want to know during the processing how the material's properties change, or how the internal structure of the material changes, and eventually how the material properties change, I need to establish some kind of a relationship between the material and the processes that have gone through. And this link is typically established by using some kind of a characterization tool. In this particular course, I'll be focusing on transmission electron microscopy, where you can get structural information, morphological information, as well as compositional information from a single technique. Here is a brief outline of the course. I'll be running through some basic principles of microscopy, the transmission electron microscopy in particular, the applications and limitations. When I show the TEM, I really want to go next to the instrument, show you what the individual components are, how the instrument functions, what are the different changes that we do, or what are the procedures that we use to start obtaining an image. I'll go through all the basic modes. So we have a few microscopes here at IIT Hyderabad. In particular, we have a lanthanum hexaboride filament TEM, we have cold field emission gun TEMs, and we have aberration corrected TEMs. But as this course is aimed at helping you start getting some useful information from a TEM, I'll start by showing you the different components of the microscope, showing you how the alignment procedures are done. I'm not sure what exactly is the very correct way to get an image from an instrument, but I'll at least tell you what are the do's and don'ts and the basic first level troubleshooting to help you get information. We'll start with looking at a lanthanum hexaboride TEM, and then I'll show you the alignment procedure, the loading of the specimen, getting some basic images. I'll start with showing you basic bright field imaging, dark field imaging, diffraction, and high resolution imaging, and how do we analyze and interpret the data that you get. I'll also focus on various specimen preparation techniques, from the conventional classical techniques of cutting, grinding, polishing, and electropolishing and iron milling, to modern techniques such as focused ion beam and SEM, where you're preparing specimens from a particular location. Also, I'll give you a few examples of which kind of systems can be studied, what are the various images we get, where are the artifacts that are coming in, what is meaningful information that you're getting from an analysis, what has to be used for getting meaningful data and to be able to present it in a publication.